Welcome, everybody. Thanks for coming. I just realized that 2:30 in the afternoon is probably not the best time to have a talk on security. But thank you all. Hopefully everybody got some coffee, and hopefully I won't put anybody to sleep with this. So first off, who am I? I'm actually not a security expert. I'm a software engineer at CyberArk. I came over as part of the Conjur acquisition. I spent most of my career in startups. I've always sort of walked on that line of like development and operations, mostly so that I could do more of the development side of things. I like building productive teams, creating thoughtful software, and despite the fact that I'm not always successful at achieving these ideals, I like to keep trying to get better at that process. Most of all, I like spending time in the mountains, walking, running, hiking, skiing, ideally with my family. I really dislike unhealthy teams, security theater, and unhealthy work-life balances. So I want to get a sense of who's here in the audience today. If you could raise your hand if you consider yourself to be a developer. Okay. How about operations? Okay. How about security? Okay. That's an impressive list. More developers than I expected, so I'm excited about that. So we're all here in Jenkins World to learn how to leverage Jenkins to improve our CI/CD process. But at this point, we've been talking about the DevOps having the DevOps conversation for quite some time. Whenever I attend DevOps conferences, I'm just continuously amazed at the range of different organizations. There's companies that are doing really, really well. There's people excited to be in those organizations. And then I always have 2 or 3 conversations with people, typically in larger companies, that are really, really struggling. I mean, years and years behind those other organizations. And really have come to believe that the reason this range comes to the change within an organization and an organization's ability to change. And so change is really, really hard. Cultural change, the kind that required to shift the way that you work, is even more challenging, especially in a big company. So I can attest to this. So prior to CyberArk, which is about 1,000 employees, the biggest company I ever worked in had 80 employees. So a pretty significant step up. So we were a startup, 16-person startup, and we moved into a 1,000-person organization with an air-gapped development network. So there was all the developers had 2 machines, one to get outside, one to do their work. So glad we didn't get rolled into that. But it was very, very eye-opening to see how a lot of the companies that we sold our software to, the experience that many of the engineers in those organizations had. And so despite the effort, it's critical that we not let this sort of stagnation take place. We need to make organizations viable in the long run, because we know, after study after study after study, report after report, that companies that are able to innovate quickly and move quickly are going to become more successful. And if you're in companies that are in spaces that don't currently face a competitor that is able to move quickly, eventually somebody's going to come in and very quickly walk over them. We've seen this with Amazon, with Netflix, with Uber. Organizational velocity is a competitive advantage. So traditional approaches to security. So let's look at the concerns organizations typically have as they begin to adopt an agile practice, and that's security. So historically, before the cloud, and everyone carried around laptops and computers in phone form in their pockets, and we deployed stuff into the cloud, everything was kept in data centers that looked a lot like fortresses. IT and security teams controlled and monitored data coming in and going out using firewalls. Machines were physically isolated. People connected to them through VPNs, so maybe you could only get into your office network by sitting at your desk in your office. Those machines were actually in a data center somewhere. And security was achieved by limiting access from the outside to ensure the data we were trying to protect didn't find its way outside the data center unexpectedly. And the strength of the exterior wall was really the best defense. So this was possible because companies only maintained a small number of data centers. So we've got this new norm, the explosion of cloud-based technologies powered by open source. We found ourselves in a world where it's possible to scale vast amount of computing power simply by sliding a little bar in a UI. Thanks to Docker, we can easily take literally the exact code an engineer wrote from their laptop, move it through, validate it, test it, put it into production, pull it back out if we find that it doesn't work as it was expected. It's a bold new world. An astonishing velocity can be achieved by small teams, moving fast and mostly not breaking too much. Thanks to Amazon, you can also have data centers all around the world with the push of a button. And many organizations run a hybrid cloud, so a mix of Google, Azure, AWS, and their own on-prem data centers. And it's pretty much impossible at that point to put security around all those different environments. So the big thing about the new tools and technologies and approaches is they address an organization's desire to move quickly, but they often fail to alleviate the very reason we built these walled data centers to begin with, which was security. So security is hard. I'm not going to kid anybody here, and anybody in security knows how hard it is. So as an attacker, you only need to find one opening in, and then typically you can move horizontally and gain privilege. As somebody protecting that, you literally need to be perfect every single step of the way, and that is a completely impossible task. But our security model is still built on those same ideals of days gone by, where we were defending things, so locking things down, slowing change, making sure we weren't introducing vulnerabilities or openings for attackers, isolation. So Kubernetes is a great example, and I'm really glad it came up in the keynote this morning, because it's literally a transformative technology. It's just over 2 years old, and I feel like it's been around. We've been talking about Kubernetes forever. So out of the box, it's fairly easy to get a stateless application running inside Kubernetes, especially with Helm charts. So how about security? There's literally nothing. It's wide open. So the Kubernetes team they were tasked with building a container orchestration tool, and they've exceeded that. We didn't get secrets, I think, until 1.6, 1.5, 1.6, somewhere around there. And even now, they're not really solid. Security is in these tools is usually a second-class citizen. It's you're proving viability first. Once you've got viability, the next thing people ask for is security. So a lot of the security folks in the room know this, and I suspect most of you are frustrated by this, because you end up in this awkward position where you're the bad guys and bad girls in your organization. You're the ones telling your engineers, no, we can't use that new technology. You can't move faster. Same with the ops team. You're not wrong at all in making those statements. But at the end of the day, the only way to enable transformation is to address the security concerns and really dig into what's preventing the adoption. And we need to do this in a way, most organizations that struggle with this are unwilling to lower the security standards to achieve velocity. There are a number of other organizations who, I'd argue, have taken the opposite tack. They've just made it easier to move fast, and through that fast, move secure. But a number of our customers, banks, anybody heavily regulated, your auditors are not going to be psyched for that. So sadly, I hear of organizations, sadly or rarely do I hear of organizations that are really killing it on the security side of the equation. I know they're out there, and I know the reason I don't know about them is they never show up in the newspaper because their companies aren't breached, they don't lose tons of data, credit card numbers, et cetera. Likely, most of us work in organizations that don't quite have that same level of security experience. So a former colleague of mine, Dan Warner, introduced me to this concept that he called experience-driven design. Dan was a UX guy. He wasn't a developer. And in essence, what this boils down to is you take the different people or personas that are going to be using your software, and you look at what their skills are and what their pain points are when they're doing their job, and really what they hope to achieve from this thing that you're building to help them. And you craft a solution that at worst case has a neutral effect for them. So like in our stuff, the developer persona is always the easy one. Like the developer shouldn't ever notice that we've slid this entire security stack in. Then we've done our job. But the security team should be really happy, and the operations team should be happy. So you want, as a collective group, you want a net positive. So I've been thinking a lot recently about this concept, and I really think it applies to a much broader set of disciplines other than just design and development. And security is one of those. So with all the things that the suggestions I'm going to give shortly, keep in mind that experience of security. So we want to craft an experience where the security is not a painful thing. It's something that's there, but it's almost unnoticeable to the user. So I've been kind of beating up on a couple of different folks or groups of folks a little bit. So security teams always get hammered for being too rigid and old school. Development teams really get hammered for just wanting to run as loose and fast as possible. I can't say, as a developer, that's completely wrong. And ops really just wants to use cool tools. I'm a support as well. But really, for me, realizing how to help organizations move forward with tools meant looking for deeper reasons for why transformation stalls. And I really believe it's security. So now let's dig back into some actionable things each of you can potentially take back to your organization to help them grow, keep improving, and bring some security peace of mind to your organization's CI/CD pipeline. So I've ordered these most important to least important. So if at some point you throw your hands up in the air and storm out of the room, hopefully at least you've gotten a few in. So before we really launch into Jenkins, I want to talk a little bit about securing the CI/CD pipeline. I want to look at the key tool in the process, and that's Jenkins. So Jenkins is a super solid piece of software. We run it internally. We've used it for many, many years. As a huge community, it's got amazing adoption in the enterprise, actually companies of all size. And it's got a solid company behind it. So big shout out to CloudBees for putting this whole thing on. But at its simplest, so Jenkins takes any code you give it and executes it, which is fantastic for running tests, but it's pretty much a complete and utter nightmare for securing Jenkins itself. It's basically a hackable environment. So I'm not saying this to slam Jenkins or CloudBees. This is just an inherent nature of CI/CD tools. They just run things, and so generally you have access to shells, all sorts of problems. So we now have to, as we're thinking about security in Jenkins and our CI/CD pipeline, we have to think about things like strace, which can be used for introspecting processes that are running on the Linux kernel. And you can use that to sort of hop from different places. So all jobs in Jenkins are spawned from the user Jenkins and the group Jenkins by default. And so this gives any jobs running on the same server now have access to the different artifacts of other jobs on that same server. Once again, I don't necessarily think that's inherently good. It's inherently bad. It can be used for bad things, but just all stuff to be aware of as you're thinking about this. There's also some strategies that we can do with slaves and tagging to provide some levels of isolation, and I'll talk to that in a little bit. So the other piece of Jenkins is they've got the open source Jenkins at least, so I'm sure the enterprise one does as well. The Conjure team runs the open source Jenkins, so most of my experience is on that side. So Jenkins has got great support for authorization, which allows permissions to be set on a per user or group basis. But with any sort of authorization, it can be tempting to just enable all, to just get it working. I've never done that before. So key plugins like the credential plugins really need to be restricted to just the users that absolutely need to use them, or you end up in a situation where anybody who can get onto your Jenkins server now has access to any of the credentials that you've securely stuck in the credentials plugin. So before, or honestly at any point, it's well worth taking some time to think about the different groups of people who use Jenkins and interact with Jenkins and understand what their needs are and give them the minimal level of permissions that they need to do their job. So sort of I defined that like minimal level of permissions is they shouldn't notice they're missing stuff on a daily basis. It's okay, like once a quarter they try to do something or make some change that they can't do something, but we want to make it so that people don't notice the security that's been or the power that's been given to them, or the limited power that's been given to them. So literally the number one thing, go read the Jenkins security guidelines. The security docs are fantastic. They won't take you very long to read. Read them, understand them, and implement as much of it as you can that you don't currently have implemented. So they talk a lot about minimizing user privilege. So another key thing to do is enable agent to master control. So this is a feature that the docs say only if you're a large enterprise. So we used this feature when we were, I don't know, when we rolled Jenkins out. It was probably like 7 or 8 people in our startup. And the reason we did it is because this gives you isolation of the slave nodes. And the key thing that it does is limits the access for a slave to communicate back to the master. So if it's not configured, a slave can actually get quite a bit of information from the master node. And that's really not something, it's really the credentials that you want to keep isolated. So another suggestion is to leverage Apache or Nginx in front of Jenkins as a proxy. So you can do things like additional LDAP type authentication with that, but even better, using that to resolve mutual TLS. So you're certain that the people who should be accessing your Jenkins are able to, and only those people are able to access your Jenkins instance or instances. So some more stuff. Please, 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 please. I hope everyone in this room answers this question correctly. Is anybody running jobs on the master? I won't shame you if you do. Okay. Thank you for being brave enough to raise your hand. Please don't ever run jobs on the master. Like the single biggest vulnerability with Jenkins, it's not just a vulnerability, it's a physical location problem. So the problem with the Jenkins master is that it has the Jenkins home. And if you've looked in the Jenkins home, everything used for encryption is stored in that folder. So there's two keys to this. We got to first secure that folder to make sure that no one's shelling onto this machine to grab keys or can get onto it through bash, such as through a job, which is why we really want to run at least one follower and keep jobs off of the master. Only run them on a follower. So downsize your master if you're concerned about saving money, and scale up your followers. And really, the key thing is just the encryption. So all the encryption stuff is stored in the home, so you've basically just exposed all the credentials that are stored on Jenkins. And the final thing is absolutely leverage the credential plugin. It's been recently rebuilt or re-released, and it's an excellent abstraction and makes it super easy to get stuff into jobs and handles it all securely. Because inevitably there's code, you're going to have SSH keys for checking code out of Git repositories. You're probably going to have credentials for publishing artifacts up to Artifactory or wherever you store artifacts, or credentials for deploying into production environments. And those credentials, of course, should never be kept in code. I'm sure everybody in this room's got that taken care of, so I won't ask anybody to raise hands there. Okay, so now that I've just told you use the credential plugin, I'm going to tell you not to use the credential plugin. And one of the, yeah?
I was actually just going to ask, which credential plugin? There's multiple versions, right?
So the Jenkins, the security page, they've got I think it's the most recent release of it. They've cleaned it up a bunch.
It's the third-party security plugin.
The Jenkins supported one, yeah. Yeah. In all transparency, we're working on one, but I would still say if you're going to choose one, use the one that comes from Jenkins. They know the most about Jenkins. If you have a centralized vault, I would then use the one from that provider. So why am I saying put all your credentials into a centralized vault? It's not because I work for a security company. It's from a security and ops perspective, it's incredibly valuable to store credentials outside of a system like Jenkins in a centralized vault. Because the single biggest reason is to avoid security islands. So what's a security island? A security island is things like Jenkins credentials and Ansible Vault and Chef data bags and anything, key value YAML file that you store in an S3 bucket. Anything like that, any place that you store credentials. And the reason for this is to limit your organization's attack surface. So if you've got all of these artifacts that you really don't want getting out because they provide access to protected resources, if you roll them all up into one, you can put your effort into defending that. Otherwise, you're dependent upon each of those individual systems to be secure. And some of them, like the Chef encrypted data bags, stuff stored in encrypted YAML is solid. But then the question becomes, where does one store the decrypt key for that? Like, just having that stuff all centralized makes things a lot easier. The second reason is visibility. So I've got this I'm clearly not a graphic designer, but I threw this picture together. So we've got a centralized vault, and we've got these 5 nodes that are all retrieving credentials from the vault. So we've got a bunch of Jenkins slaves, and we've got some prod UIs, 2 of them. So normally, with a Jenkins plugin, anytime that plugin grabs credentials and drops them in a job, they're going to show up in the Jenkins log. So in the Jenkins world, that's fine. So now that we've centralized things, we don't need to worry about whatever is pulling credentials. We just need to look at the credential vaults log, audit log, to see. So we know the Jenkins slave 1 pulled these particular credentials, and Jenkins slave 3 pulled this other set of credentials, and our prod UI pulled a different set of credentials. We don't need to we should have good logging through there, but security has to just look at one place to understand who had access to what, when. So the other big reason is rotation. And let's run through a quick scenario of rotating a GitHub API key in a high velocity environment with lots of jobs. So first we need to log into GitHub and create a new API key with the same permission as the old key. Then we need to update the credentials in each system that has them, so Jenkins or Ansible, et cetera. Then we need to rotate out the old API key. So the more security islands you have, the more challenging rotation becomes, and the less likely you are to actually practice rotation. And so I won't ask anybody to actually answer this, but how many people can easily rotate your credentials without causing chaos? How many people practice that with any regularity? So if there is a breach, it becomes critical to rotate everything that was exposed. And so if an organization can rotate things quickly, they can close the breach, move on, do the full analysis, and move on with life. But if rotation becomes this massive thing where we're starting and restarting systems, and we got to coordinate, and things got rotated, but credentials not updated, then you end up in the pain that is, the data breach. So our goal with this is really to increase our team's velocity and ability to deliver more value more quickly. And centralizing allows security teams to deliver least privilege at an organizational level, while users and machines have access only to the credentials they need to do their jobs. So at this point, we've talked a lot about the physical or visible access to Jenkins and infrastructure in general. So there's a bunch of layers of security to keep in mind, especially in the build process. So key reason we implement CI/CD process is to be able to quickly deliver changes with confidence. So your biggest risk today is likely isn't your infrastructure, but more likely your software's dependencies. So the Equifax breach was just a complete bummer, because the Struts team had literally fixed the problem. The Equifax team just was not able to roll that fix out in time. And so one of the things that we've started to do internally is add static analysis, and we do actually static analysis, linting, and then vulnerability scanning on all of our libraries. For most of our projects at this point have it. So pretty much every language at this point, or every common language, has static analysis and vulnerability scanning libraries available. Add them to your pipeline and fail builds and fail them early so the developers can fix them incrementally rather than having to do these massive upgrades when really big ones come out. So static analysis helps to ensure your internal code is solid. The vulnerability scanning I think is more important because it's scanning for known vulnerabilities. The reason it's more important is there's a fair amount of automated software at this point that just scans sites for vulnerabilities and notes them for potential exploit. So just wanted to give, oh man, that's kind of not super clear. Just kind of an example. This is from one of our projects. So we run, this is a Ruby project, so we run a tool called Brakeman, which does static analysis, and it's all run in parallel. So this thing takes like 10 seconds to execute. And then down here looks for gem vulnerabilities and then does linting. So pretty straightforward. So the CyberArk Labs team recently released a really good post of successful hacks that they were able to do with Jenkins on a Jenkins server, and we did work for full transparency. We did work with CloudBees to fix the concerning ones before we released the paper. But my biggest takeaway from the report was how many issues could have been prevented with good code review best practices. So a lot of the exploits used tools like strace to look, to do like, just to peer around things that were running on the same instance as that test ran, and you can see things. I'll say that the blog is on the CyberArk blog if you're interested in looking. It's definitely a good read. I always like reading stuff like that because I love the way that security mind thinks, like especially that hacker mind thinks. So reading through all this stuff though, I realized our team internally had a really good process in place already for dealing with these types of changes or these types of concerns, which is just the review process. So the way we've set up all of our branches is master requires at least one approval from another team. And so it's unlikely to get an inside attacker, but having code review, a good code review culture pays benefits in this place because you're going to catch things like that. And probably 9 out of 10 times it's not even an intentional thing, especially if you're trying to troubleshoot something. And then it's got the added bonus of the fact that you're bringing code review into your organization, in your team. So you're going to get increased knowledge transfer, learning. I can't say enough about code reviews. So another thing to think about is where information comes back to the people who need that information. So the average software developer interacts with Jenkins through tests. So instead of having them log into Jenkins to check test status, move that stuff out into PR status on GitHub or put it into Slack. Even put like what the failing tests were in Slack. Don't make them log into Jenkins. And then you don't, it's like if the tree falls in the forest, does it make any sound? If you're not in Jenkins, if you don't need to get onto Jenkins with any regularity, and there's stuff that is exposed in Jenkins, then it's visible only to the people on the Jenkins. So if you can, as much as you can move people off of Jenkins, keep information flowing out of Jenkins. Let Jenkins be the central traffic cop. You're going to close up some of the harder security problems to face. The thing you want to avoid is eliminating shell commands on your Jenkins server, because you're just going to make your life harder for everybody. So simple things are, the other big one, and kind of weird one might be, make sure the tests can be run locally. So simple things are easy to reason and understand, and complex things create confusion and misdirection. So make sure all relevant stages of your pipeline can successfully be executed locally by a developer in a reasonable period of time. And I know for some organizations this is a massive ask. So when Jenkins 2 came out and got stable, one of our engineers had the incredible foresight to basically rebuild all of our Jenkins infrastructure on top. So we ran a combination of Jenkins 1 and Jenkins 2 in parallel as we were moving projects over from 1 to 2 for pipelines. And so the approach we took was to rebuild all of our projects on those test pipelines. Each stage has a single bash script as an entry point, and everything is put into a Docker container. So we run Terraform in a Docker container. We run Chef and Ansible in Docker container, like anything that can. So we wanted to reduce the things that we needed to install onto our Jenkins followers in order for tests to run. But most importantly, we wanted developers to be able to run those tests locally. Because what we'd found is no one wanted to touch Jenkins. And so it was like, once again, was brought up in the keynote this morning, it was the hot potato that was like the whole key to delivering anybody's code into production, which is completely crazy. So once we pulled that down and things became, simple is not quite the right word, but simpler, all of a sudden developers started writing more tests and they started writing more integration tests. And we started to get some patterns for how to write those tests. So collectively, things moved a lot quicker. And then you also can start to parallelize tests. So I just grabbed another example. Actually, this is from the same project. So we run RSpec as a unit testing framework. So in parallel, we run RSpec, and then we run this kind of crazy series of different integration tests that would take, I think this one went down from like 40 minutes to like, I don't know, maybe 7 or 8 minutes. It runs now in parallel. So you can take advantage of some of the parallel abilities of Jenkins. Okay, so we're here because we're trying to learn how to get better at delivering software. So here's the truth. If you're just getting started, it's going to get messier before it gets better. Despite that, it's well worth the effort to keep moving forward with a high degree of automation. When done, things bring a significant reduction in risk as well as radically improve the experience of those working on shipping value. So everybody's going for that upper corner, but like the mess, it gets messy before you get up there, because until everything is running in that unified system, everything's humming along, you're going to end up with a hodgepodge of things. So you've got to just keep moving. So I caution anyone from believing you can buy your way into DevOps, despite us being at a sponsored DevOps conference. It really requires a collaboration, communication, empowerment, and most importantly, building tight feedback loops. So at any point in time in your digital transformation, you need to understand the most valuable problem your team needs to address to improve the organization's net velocity. And build these feedback loops in first, and then you'll understand what your team truly needs from you. So focus first on the feedback loop, and the feedback loop will determine the tools that need to come in at the natural place the tools will need to come in your evolution. And as long as you've got a feedback loop, if you ask people what's bothering them, I've never had anybody say they were perfectly happy. And when that day comes, we've done it, we've won. So in summary, so really good security is really a collaboration between development, operations, and security teams. Always just focus on velocity, and really think about the humans in this equation. We build these incredibly complicated systems, and we're responsible for these incredibly complicated systems. But I feel like, myself personally, I can often forget that there is somebody on the other end of that software. And really, when you're working in the CI/CD space, it's easy almost to forget that there's somebody on the other end of the space, because those people tend to be so technical, they're able to work their way through these like really hard challenges. So as you're building and designing things, think about the people using it, what they need, and basically what they need to do their job. Design security around that, design the tools around that. Keep in mind also that security covers more than just infrastructure. It's also the code. I think the majority of breaches actually have come not out of directly out of network breaches, but out of breaches that have happened through public-facing websites. And above all, continuously improve. So that's all I've got. Questions? Yeah?
So when you were talking about moving assets into a vault, how would that get integrated with Jenkins there? Are you saying these other vaults have plugins that would work, or what would be the way of actually using those with Jenkins?
So the question was, how do you move, or if you're storing credentials in a centralized vault, how do you get them back into Jenkins? And so there's a number of different tools. We've got an open source tool called Summon, which is just a generic tool that lets you inject things into a process. We've got integrations for Conjure, for CyberArk. There's an integration for HashiCorp Vault, File, S3. We've got a variety of different options. We use Summon really heavily in our process to keep things out. HashiCorp has a new tool. I want to say it's like Vault Client, something like that. If you're a Vault user, I'd recommend using something like that. A big reason that we moved to those shell scripts was to simplify that process of, like, this thing is going to need credentials. We'd use Summon to start up that child process. Credentials would be available during the lifetime of that process, and then when it was done, those credentials were gone from the system. Any other questions?
So in another class, they echoed the same thing about not running any jobs on Jenkins masters except for backups.
Mm-hmm.
Do you say that backups are okay? Do you back up Jenkins home, or is this a commandment, thou shalt not run jobs on Jenkins masters? I mean, where should we go on something? Use our best judgment?
So the question was, can you run backups? I said never run anything on your Jenkins master. Not thinking honestly about backups. And I would say, no, I mean, first off, always use your best judgment. Process should never take the place of logic. And do what makes sense within your organization. And the same, I'm sure there's a mechanism for encrypting backups. So like any backups like that have sensitive data, as long as they're stored encrypted, like they're fine. But yeah, if your Jenkins master falls over and you have no way to recover, you're in a bad place. So yes, address that first. Yep.
I'm just wondering, are you aware of any tools like for static analysis for Jenkins files? I see lots of hard-coded passwords and stuff like that. It's just, yeah, I need something like that, not just for the code, but also for the
I'm not. So the question was, am I aware of any tools for static analysis on Jenkins files? That's a really great question. So CyberArk has a tool, we call it DNA. That's a general scanning tool. So it scans through Ansible playbooks, a variety of different sources. I can't say for sure if that would solve it, but something like that. But if that tool doesn't exist, that's a great, great place to start.
It's possible that SonarQube would do it. It's groovy. So it's like
Oh, yeah.
groovy, it'll scan. And if they've got a credential that looks
Okay.
like a credential, they call it
What is it called?
my password.
Jenkins file is basically a DSL code.
Yeah, a Groovy.
It's groovy.
Yep.
It's groovy code.
Okay.
Pipeline is not necessarily good.
That's true.
It might not represent as well.
The other day was saying about the plugins. It's about the security in the plugins. If you use a lot of plugins, the plugins are not officially supported, so it will be a security risk.
Yeah.
Start to use whatever plugin you found
Yeah.
in the wheel.
Yeah. And that was the other reason we rebuilt. We went from using, I mean, it was crazy. We had a ton of different Ruby versions, Go binaries. It was just a hot mess. And moving everything into Docker containers helped.
Maybe it's not about the platform, maybe it's about the teams. You know, in big organizations, probably all the development teams are from outsourcing. That should be a security concern about the profile, about the rights that developers have over the platform, over the
Yeah.
you have some experience about that, how to manage the permissions on the dev teams.
So the question was about for exterior contractors.
External contractors.
How do you?
Banks, for example,
Yeah.
use a lot of external contractors to
how to have them help build software, access key systems, but not expose them. So there too, I think making sure that your pipeline is largely runnable locally can help. And the other piece would be just moving key bits of information out. So like if you can dump via Slack, like specifically just, I mean, you almost care less about successful builds, but failing builds, like what tests specifically failed on a branch.
That's especially risky when you have the Jenkins file in the same repo code with the code the external team are using.
Yes,
They have the access to the Jenkins file.
they do, yeah. Yeah. And that, we have the same thing, and that's been it's been a benefit for our team, but we fully trust everybody. I'm not entirely sure.
It is tricky because all the DevOps philosophy is about trust. You trust in your people.
Mm-hmm.
But big organizations don't trust their people because they are not their people. They are external contractors.
Yeah.
So they are not my people. So it's hard. It's really tricky.
Yeah. Any other questions? Yeah.
More of a comment. Like, so for this particular question that you had, if you have Jenkins file together with the regular code, you can have if you're using GitHub or something, you can have a pre-commit hook which would actually validate your Jenkins file to make sure that it contains or it's in the proper supported format, right? So that they didn't just remove the content of it and just go remove everything from Jenkins.
That's a good idea.
Plus code reviews.
Yeah. Yeah.
Not to use shell scripts, build, but I guess I'm not quite understand what you mean, but because I'm using shell script to call my build.
No, so let me clarify. The question is about shell scripts in the build process. More of just like an awareness. I think the thing that's fantastic about Jenkins on Linux, like you have all of the bash, like the whole shell environment available to you. But because you have that, you also have a lot of exposure into the processes that run. And so jobs, because they're able to execute bash cleanly, can see other jobs. They can see, like, not necessarily, well, with that strace, you can see some memory stuff. But I say that more in the sense of things that you're concerned about, like just create physical isolation between them. So we run 2 different sets of slaves. So slaves that are just build slaves or just test slaves, and then we have like 2 slaves that are publish slaves, and those are the only instances that have access to the credentials to publish stuff up into our Docker repositories and artifactories, repository, et cetera. Because we're a little more concerned about that stuff getting out. Like we don't want general build jobs to be exposed to those other jobs. So you can use physical server isolation to create isolation within your CI/CD pipeline to combat kind of the raw power of Linux that you're running with Jenkins. Any other questions? Awesome. That's all I have. Thank you, everybody, for attending.